actually start. So what you're looking at here is the what you might call targeting software. And for our targeting software, we use software called Astroplanner. In our earlier broadcast, we've already gone through M42, M44, this NGC 1499, M1, and M45. So we're ready for this spiral cluster here. I'm going to do one more sort. Make sure that we were a little bit off from objects being moving around. Let's try going to this Rosette Nebula. What we're going to do is we're going to slew the object, and while we're slewing, we're actually going to let you see that slewing process. So you can hopefully see the scope moving there with the webcam. And that also lets you get a good view. Let me brighten this up a little bit for you. Um, it's a Celestron Roe Ackerman Schmidt astrograph 8-inch telescope optical tube assembly with a Skywatcher EQ6R Pro mount. And you can see the cabling perhaps that comes down and comes into Ford Expedition, which is also a part of my gear. And that Ford Expedition is a big part of the gear. It's 70. Actually, I've got it turned down a little bit now. 69 degrees in here. And outside, the last time I checked, it was 24. Feels like 24 degrees. So that'd be kind of brutal out there, wouldn't it? What we're going to do now is go to SharpCap, and we're going to let SharpCap know that we're going to look at NGC 2237. So here we are in SharpCap, and we're going to say NGC 2237. That's the Rosette Nebula, NGC 2237. And we're going to, let's see, let's do a bit of a reset there and a stretch. And then let's do a plate solve. And what plate solving does is examines the stars that the camera is viewing and then cross-checks the stars with its own database of what it thinks should be stars. And you can see what it's doing there. It's actually correcting the mount a little bit. It was a little bit off, wasn't it? Just minutes of a degree off. And it centers things back up again, so we make sure that the Rosette Nebula will be in the middle. So let's do one more reset of this display histogram. And if you're curious, we're at 10 seconds per exposure now with our ZWO ASI 183 camera, which is mounted at the forefront of this 8-inch telescope. We have a 200 gain going on. Now what we'll do is what's called, see, I've already set the title correctly, it's live stacking. We're going to clear that previous live stacking. And then we're going to, we're going to go down here and once again reset the display histogram and do an auto stretch on that. And then we're going to reset the color and reset this histogram and do an auto stretch on that. Let's reset the color one more time. It'll probably take a while before it can do an effective restretch of the colors. While that's happening, we could go over to our what we call our planetarium software, Sky Safari, NGC 2237. So let's send you to our, here we go, send you to our planetarium software, NGC 2237. So what we're going to do is we're going to search for that here, NGC 2237. Oh yeah, that's beautiful. It's looks like it's a pretty tricky object. Let's center at it, and there you see it. It's pretty tiny. So if you get a sense of the sky, let's kind of back up and get a sense of where we are. So we're looking there's due south. We're looking due south, and we're looking just to get a sense of where the zenith is. The zenith, of course, is straight up. So we're looking about halfway up the sky. Now, just for orientation, there's Orion. If you've ever seen the three belt stars of Orion, and there's Betelgeuse and Rigel, the two stars. This would be the guy's, his right shoulder. What we'll do now is we'll kind of zoom in a little bit. Let's just say center object, yeah. And my goodness, it's a pretty big target. This rectangle actually is a representation of the field of view that we have in our camera. So let's go back over here and see what SharpCap is doing. We're going to first of all send you back to SharpCap. SharpCap is the software we use for viewing, and this telescope is a little bit strange compared to most. There's not even an eyepiece in this telescope. So it means that, there you can start to see it kind of beginning to come into play. There's not an eyepiece. You just have to use the camera mounted on the front. And what we're doing now is setting this thing called a histogram. We're going to set it right about there, I think. And then we're going to start trying to bring in that nebulosity. Right there it is. Look at that. Isn't that beautiful? And then let's reset our color. I'm not great at colors. Part of it, I think, is just because of my color blindness. Wow, but that is amazing, isn't it? Wow, NGC 2237, hello. Think of that, that's up there all the time. It's just waiting for somebody to come and see it. How about that? Okay, I think we're going to go over here to our planetarium software. And look, there's an audio tour of this object. Let's play it.
This is the glorious Rosette Nebula, a very large flower-shaped nebula within resting the star cluster 2244, make the Rosette one of the most photographed objects in the sky. It is, however, somewhat disappointing to the unaided eye. The nebula is very bright in the red portions of the spectrum to which the human eye is insensitive. Therefore, with red-sensitive film, it may be made almost as bright as the Orion Nebula, yet visually hard to spot. The Rosette Nebula is one of those large complexes of gas in the neighborhood. Its size is more than double the width of the full moon, and in very dark locations it may be glimpsed with the naked eye. The nebula is thought to contain enough gas to make 10,000 copies of a star as massive as the Sun.
Wow. Now see, we're playing with the color bars here. And like I say, I'm not very good at this because I do have some color perception problems. So I tell you what, let's do. Let's just auto color balance it. And that's what the computer thinks. That's what SharpCap, which is the name of the software, that's what SharpCap thinks it ought to look like. Now, I'm going to go over to our planetarium software, and I'll be honest with you, the planetarium software believes that there should be a lot more reds in there. This is the most we can do with it, so I'll tell you what, we'll decrease this green just a little bit. Oh yeah, that's much more faithful to the look and the feel of what the planetarium software thinks it should look like. Now I'm going to play a little bit. I'm going to hold my shift key down as I try to play with this mid-level tones. Wow, can you believe that? If you were to try to look up in the night sky to try to see this, I don't know if you'd be able to see it with your naked eye, just because it is scattered out so much. This is 80 by 60 arc minutes wide. So it's very large, but what that means is the surface brightness is going to actually be averaged out. And what's funny about this nebula is it actually has the names of 5 different nebulae in it. And let's see, what people normally do is use NGC 2237 to describe the whole thing. So they typically would call this whole thing NGC 2237. Then the part that is the small faint star in nebulosity is 2238. What I'm going to do is I won't take you away from the actual nebula, but I'm going to go over to the planetarium software and see if I can find 2238. NGC 2238. Nope, it's not gonna show me. Maybe if I zoom in some more. Boy, I think I would just have to get a better map of this. I'm trying to zoom in and see what parts are what. NGC 2244. So NGC 2244 is the central part, they say. And then the rest of these, it's not giving me much detail on. I'm sorry, I can't really find you too much on that. I kind of wish I knew more about which part was which, because to me I find it fascinating. 2239 is the part that has the star of magnitude 8 in the large bright cluster. NGC 2244 is what they call the open cluster within the nebula. So that's this, definitely. NGC 2244 is this open cluster. And then NGC 2246 is the extremely faint, large, irregularly round, extremely difficult. Wonder if we can pull that out. Let's start playing with this. That's just beautiful, isn't it? I mean, it's just plain beautiful. So what we're going to do now is capture a photo of that, the way we've stretched it. It just looks surreal, doesn't it? I mean, can you imagine walking out of your door to walk your dog at night and you look up in the sky and you can see that? Well, guess what? It's up there all the time. Now, it's a long ways away. It's 5,500 light years. 5,500 light years. So, just to put things in perspective, the moon is just what? Is it like what? 240,000 miles, something like that, I forget. This thing is 5,500 light years, which means the light that left this object, this vast cloud of dust and gas that is a full degree across, it's basically 5 times the width of the moon. And the light that left it has been traveling for 5,500 years. That just seems impossible, doesn't it? There are these little photon packets that have been crossing open space toward us. And what we did is we opened up this 8-inch light bucket and we put a camera at the bouncing light through it into this camera, and into these little CMOS light chips bounce these little photons. It basically says here in this text that it's difficult to spot. But if you have good sky transparency and a wide field, and that's what we have with this Rosette, it's famous for its wide field, then you can see this faint glow and this central hole. I tell you what, we are spoiled here. This is an amazing view let's save one more shot of this as it is. And then what I'm going to do is end this practice uh, live stream because I finally feel like this came together and I want to quit while I'm ahead. So thanks for tuning in to this shorter live stream of NGC 2237, the Rosette Nebula. And if you want to be notified of times when we are doing these observations, would you just stop by the website emeraldhillskies.com? That's emeraldhillskies.com. And you can put your email address into a form there and hit submit, and you'll be notified usually a couple of days before viewing. Once we find a night that's going to be clear, you'll be notified by email, and you'll be told exactly when we'll start. And you can always go to emeraldhillskies.com to see the link that'll take us to the live stream site, our channel on YouTube. Thank you for stopping by, and we hope to see you again. I guess we'll quit for now, but I'm kind of amazed that this now worked out. So